So we just spent some time talking about what negative gene regulation looks like, but now we have positive gene regulation. So positive gene regulation, a great example of this can also be found in E. coli. And we talked about how E. coli uses lactose for energy, but preferentially it likes to use glucose. So it's only going to use lactose when glucose is in short supply. Even if lactose is present, it's not going to try to use it. However, when glucose is scarce, something known as CRP, the CAMP receptor protein, kind of acts as an activator for transcription. So we're still going to be talking about the lac operon, but now we're going to be talking about some positive gene regulation. Cyclic AMP is a substance that begins to accumulate when glucose is scarce. So when there's not a lot of glucose in the area for the E. coli to use, it's going to start producing cyclic AMP. And the cyclic AMP receptor protein, CRP, is the activator for transcription. So this activated CRP is going to attach to the promoter of the lac operon. And this kind of increases the affinity for the RNA polymerase, meaning it makes it easier for the RNA polymerase to bind to the lac promoter, and this will speed up transcription. So once the glucose levels increase, we get more glucose back. CRP is going to detach from the lac operon, and transcription will continue to proceed at a very slow rate, even if lactose is present. So CRP also regulates other operons, but the best example to use is the lac operon. So once again, I'm going to just explain this using the picture. When lactose is present and glucose is scarce, cyclic AMP is going to be produced. So the CAMP level is going to be high. And because of this, we're going to produce a lot of lac mRNA. So the cyclic AMP binds to the CRP, which is the CAMP receptor protein. And once again, this is an activator. So this activator is going to now bind to our promoter, and that's going to make it easier for RNA polymerase to attach to the lac promoter and proceed with transcription of the lac gene. So this is the same lac promoter you saw earlier. On the other hand, when lactose is present, and glucose is present, but when we have lots of glucose, our CAMP levels are going to be low. So there's not going to be any CAMP being attached to the CRP. CRP is going to remain inactive, and our RNA polymerase is less likely to bind in this case. It could bind and produce these genes, but it's not going to do it as well. However, keep in mind that our lac repressor is also inactive because lactose is present. So the promoter is still available, but it's not as likely that transcription is going to occur. It occurs much more quickly when we have the activator here. So in this way, the lac operon is really under dual control, so to speak, because in one situation, we have an on and off. So when the lactose is present, the operator is turned on, and when lactose is not present, the operator is going to be off. So that's our on and off switch. That's our negative feedback. And this just controls whether these genes are transcribed at all. If this were gone, if there were no lactose, the repressor would be active, it would bind here, and we would get transcription, or we would get no transcription. However, when lactose is present, transcription does occur. The other piece of the puzzle occurs with our positive regulation. And this positive regulation is because this is regulated by whether or not we have the CAMP levels. So CAMP, when that's present, It's going to bind to this, and once again, you're going to end up with more transcription than if there were no CAMP. So transcription, remember, can still happen in both of these cases because lactose is present. But without the CAMP, it happens a lot slower. So the way you can kind of think of it is the first control, which is the lactose, the negative feedback, is like on or off. If there is lactose, transcription can happen. If there's not lactose, it will not happen. The other control with the CAMP, the activator, is just kind of a way to activate further transcription, and the CRP, the CAMP receptor protein, really controls the rate of transcription. So you can almost think of it like a volume. When there's CRP present, we can turn up the volume, produce a lot more, much more quickly, a lot more of these enzymes. If CRP is not present, it's going to take a lot longer to get what we need. And that is positive regulation of your genes.